Okay, it's time to tie together what we've looked at so far. We've looked at lines and how to write equations for lines. And then we looked at angles. And now it's time to kind of put those topics together and talk about parallel and perpendicular lines. Now, perpendicular lines, of course, are lines that intersect at right angles. So two lines are perpendicular if their point of intersection forms a 90-degree angle. So let's take a look at this. Let's suppose we have three lines. Here we have three lines, line 1, line 2, and then this one over here, line 3. So we have these three lines, and I want to just take note of a couple of things about line 1 and line 2. Notice for line 1, if we're at this point right here, and we want to figure out what the slope is, okay? So I'm at this point, and I pick out another point that's easily recognizable. In other words, I can recognize the value of this point right here because it's right here on the intersection of these grids, okay? So if I start here at the point, 2, 1, how do I get to this point? Well, I want to go over two places. Now remember, we're going to call that delta x equals 2. So we go over 2 and then up 1, 2, 3. Delta y is 3. So to get to any point, if you are at any point on this line right here and you want to get to another point, you go over 2 units to the right and up 3 units. So we have delta x is equal to 2, delta y is equal to 3. Now, let's look at the pink line here, okay? L2. Notice we'll start here at this point. Notice we go to the right 2 and up 3 to get to this other point up here. So on this one, delta x is equal to 2 and delta y is equal to 3, just like the line before. Now, when that happens, whenever you have delta x and delta y are the same for these two lines, we say that these lines are parallel. They never intersect on the plane. If you have two lines on a plane with the same delta x and delta y, then those lines will never intersect. And in fact, if you look at the slope for L1, it's 3 over 2. Remember, delta y over delta x. And the slope for M2 is 3 over 2 as well. So these lines have the same slope. They pass through different points, but they have the same slope. Now, let's look at this other line, L3. And I'll just pick any point on here, like, for example, let me just pick, and let me change this to green. Okay, so I'll just pick a point. Here's a point right here that I can easily recognize. It's -1, -2, -3, -4, -4, 2. So this is a point -4, 2. Okay. Now, I want to know, how do I get to another point? Well, I can go over 1, 2, 3. There it goes. Now it's lined up with this point. And then I go down 1, 2. So delta x, I'm moving to the right 3. And then from there, I move down 2. So delta y is -2. Now notice how these compare with L1 and L2. L1, delta x was 2. And delta y was 3. Now notice delta x is 3 and delta y is not 2, but -2. So notice how the delta x and delta y were swapped and one of the signs were changed. So the 2 went over here and the 3 went over here, but I made the 2 negative. Now, whenever that happens, whenever you see that kind of relationship, and notice the slope is -2 over 3, see? -2 over 3, right here. And notice how that compares to this slope. They are negative reciprocals of each other. If you have a slope and you want to find the slope of a line perpendicular to it, just flip it and change the sign. So 3/2, the perpendicular is -2/3. Okay, so there it is. That's called the negative reciprocal, and those two lines are perpendicular to each other. Now, what I want to do is, now that we have that and we know how parallel lines and perpendicular lines compare slope-wise, I want to go ahead and write equations for these lines. So first of all, L2. Now it looks like down here the way I labeled these is off a little bit, so let me correct that. So here I want to start off with L2, the pink one. Okay, so I've got, and let me go ahead and label this L1. Okay, so when I was preparing this, I mislabeled those. So we're looking at the pink line first, okay? And I'm going to use this point right here as my point. Remember, I need a point and a slope to give the equation for a line. So look, here's what I have. I know the slope is 3/2. So here's what I want to do. I want to say y minus the slope, y minus the y, 6, equals the slope times x minus the x of the point. So look, what we're doing is we're using y minus y naught equals m times x minus x naught, where x naught and y naught is just some point on the pink line. Okay, so here's the x coordinate, here's the y coordinate, and here's the slope. And that right there is the equation for L2. Now that's one way to write it. Now remember, we're doing parametric forms also. So with the parametric form, we have the delta x times some number t plus x naught, and then we have delta y times some t plus y naught. Okay, so this is the parametric form of the line. And notice how that's going to be. Delta x is 2, so we have 2t plus the x is 1. And then we have the y, that's 3t plus 6. And that is the parametric form. Okay, so we have the point slope form and the parametric. Okay. Now usually this parametric stuff is something you don't see until like you start to see it in trig when you take trigonometry, but we're introducing this early here. So these are two forms of that same line. Now let's look at the blue. Let me change my pen color here. Okay, so we have y minus 1 equals 3/2 x minus 2. Okay, and notice they have the same slope. So this is going to be very similar. It's going to be 2x or 2t plus 2 and 3t plus 1. Okay, and notice we still have, notice the 2 and the 3. Here's the 2 and the 3. What's different is the point. 1, 6, 1, 6. 2, 1, 2, 1. See? So there's the difference. Now, what we want to do next is we want to write the equation for that perpendicular. So here it goes. Y minus 2 equals negative 2/3 x minus a negative 4. Well, that would be an x plus 4. There it goes. Okay. See, the plus 4 came from the fact that we're doing x minus a negative. So x minus a negative 4, that'd be a plus. Okay. And then we have this. We have 3t minus 4. See? 3 up here. And then negative 2t plus 2. See? Negative 2. And here's negative 4 and positive 2. Okay? And there we have our two ways for each of those lines to express them as an equation. Here's an equation and a set of parametric equations. Okay. Now, I want to talk about slope-intercept form. So let's just take this first line. Let's take L2. And I want to write that in slope-intercept form. So what we have is y minus 6 equals 3 halves, and then x minus 1. If we want to write this thing in slope-intercept form, what we have to do is just solve for y. See, because what I have right now is I have a y minus 6. So here's what we want to do. We want to have something that looks like this. Okay? And when we do that, what we have here is b. That's where this graph crosses. That's where the line crosses the y-axis. Okay? So let's see about that. So here we go. Now I want to solve this. So one easy way to do this, whenever you have fractions, one of the things that makes your life a little bit easier is if you multiply both sides by the denominator. So I'm going to multiply both sides by 2. I'm going to multiply the left-hand side by 2, and I get 2y minus 12 equals 3x minus 1. Now, all I did was I just multiplied both sides by 2. Okay? And I distributed the 2 through here. Now I don't have to worry about that fraction anymore. So here's what I get now. I get 2y minus 12 equals 3x minus 3. Add 12 to both sides and I get 2y equals 3x plus 9. Now divide by 2 and I get y equals 3 over 2x plus 9 halves. And there is my slope-intercept form. And notice you got the same slope, 3 halves. And here is where it crosses the y-axis. And notice you've got, up here you've got 1, 2, 3, 4, 4.5 right there. And 9 halves is 4.5. So once again, let's look at L1. L1. Let's see how we do this. We've got y minus 1 equals 3 halves x minus 2. Multiply through by 2. There's what we get. Then clear my parentheses. Look at that. Okay. Then add 2 to both sides. And divide by 2. Yeah, so now we have a y-intercept of -2. And look, sure enough, there it is, -2 right there. Okay, so this is how we, really what I'm doing here, this is kind of a remix for how you write the equations for lines in different forms, but also now introducing this idea of what happens, how are lines and their perpendiculars related. So here's the assignment that goes with that, and we'll talk about that in class.